Evaluating formulas. A formula is just an equation that is an expression between two or more variables. Let's look at a particular formula. The formula F is equal to 9/5 C plus 32 gives a relationship between the temperature in degrees Fahrenheit, which we use in the United States, and degrees Celsius that is used all over the world. Now you'll notice in this formula, F is all by itself. So you would say that Fahrenheit is isolated and Celsius is in the equation. So if it is isolated for F, you would call this solved for Fahrenheit. If the formula is solved for Fahrenheit, then this is the version you use if you want to know the temperature, if you know the temperature in Celsius and want to know the temperature in Fahrenheit. So you know Celsius, you want to know Fahrenheit. Let's do an example. What is the temperature in Fahrenheit when the temperature in Celsius is 35? So we know Celsius. We want to know Fahrenheit. So we'll use this version that is solved for the thing we're looking for, which is Fahrenheit. So all you do is you simply put 35 where you see the C. And if you want, this is a good place to practice, so you could hit pause and do it on your own. All right. So 35 is the same thing as 35 over 1. 5 goes into 35 7 times exactly. 9 times 7 is 63. 63 and 32 make 95. And you always want to give the units with your answer. So that's written as 95 degrees Fahrenheit. So if you're traveling to another country, you look up the temperature. If it's given in Celsius, now you know how to find it in Fahrenheit, and you can pack for your trip. All right, let's look at another version of this same formula. All right, so if you take that previous formula and isolate Celsius, and you would say that is solving for Celsius, and that would be the subject of another video. So for now, we'll just give you this other version. So it's the same formula, only now Celsius is isolated and Fahrenheit is in the formula. So this is the version you use if you know Fahrenheit and want to find Celsius. So whenever you're looking at a formula, the one that's by itself, the variable that's isolated, that's what you're going to find using that formula. The variables that are in the formula are the numbers that you'll use. So let's do an example. All right, what is the temperature in Celsius when the temperature in Fahrenheit is 212? And some of you may recognize this number. That's the temperature at which water boils at sea level. And if you do any mountaineering, you'll learn that water boils at a lower temperature at higher elevations. Okay, but this is at sea level. So we know Fahrenheit, we want Celsius. So we're going to use this version of the formula where Celsius is isolated. So to find the Celsius, we simply put 212 where you see F. And again, if you want to try simplifying that on your own, you can hit the pause button here. So from the previous chapter, we learned the order of operations. You simplify the inside of the parentheses first. 212 minus 32 is 180. So 5 over 9 times 180. And remember, because I've simplified everything in the parentheses, I don't need them anymore. Because 180 is a whole number, you can think of that as 180 over 1. I'm just going to rewrite the steps so it'll be cleaner in your notes. So 9 goes into 180 20 times. 5 times 20 is 100. So water boils at 212 degrees Fahrenheit or 100 degrees Celsius. You would write it this way. All right, let's look at another formula. All right, here's a formula that we've been using all semester, the area of a rectangle, which is the base times the height, or you could also call it the length and the width. But let's use this to learn a new formula. So if you were to take this rectangle and draw a diagonal and wanted to find the area of this shape, well, what is this shape? It's a triangle. It has the same base and the same height as this rectangle. And you can probably tell just by looking that the area of this triangle is half of the area of the rectangle. All right, so let's find the area of a triangle whose base is 20 centimeters and whose height is 7 centimeters. So we simply use the formula for the area of a triangle, which is 1/2 of the base times the height. And like we talked about before, this one is isolated for area. So that's what you use this version of the formula to find the area. That's 1/2 times 20 times 7. 1/2 of 20 is 10. 10 times 7 is 70. And don't forget to put in the units. So we have centimeters times centimeters or square centimeters, or you can write it centimeters squared. Now you're probably already thinking, well, this is a particularly nice looking triangle. And in fact, it is. This is called a right triangle when one of the angles is 90 degrees. And you might be wondering, does this formula work for any triangle? And the answer is yes. And let's look at another triangle. All right, here we have a triangle that is not a right triangle. Let's find the area of this triangle. So we're finding the area of this triangle, which is not a right triangle. So the base is this long side, that's 12 inches. And the height is this length from the tallest point. So that's 5 inches. All right, so from before, we learned that the area of a triangle is 1/2 times the base times the height, which we derived from half of the area of a rectangle. And so that you can visualize it, I'm going to draw a rectangle. So I have inscribed the triangle into a rectangle. The height of this rectangle is, that's right, you guessed it, 5 inches. And the width is 12 inches. So the area of the entire rectangle is 12 times 5. And you can see that the area of the triangle is half of this rectangle and half of this rectangle. So the area of this triangle is 1/2 times 12 times 5. 1/2 of 12 is 30. 1/2 of 12 is 6. And 6 times 5 is 30. All right, let's make sure we have the correct units. So we multiplied inches times inches. So that's inches squared, or you could say square inches. All right, according to exercise physiology, your maximum heart rate, which is the theoretical fastest that your heart can beat, is found by subtracting your age from 220. So that formula, maximum heart rate, is 220 minus your age. Let's do an example. All right, what is the maximum heart rate of an 18-year-old? So we're looking for M, the maximum heart rate. We simply put 18 for the age. 220 minus 18 is 202. Let's do one more. So what is the maximum heart rate of a 60-year-old? So we just put 60 in for the age. 220 minus 60 is 160. So you can see the older you get, the lower your maximum heart rate is. So you can use numbers like that to help you gauge your exercise. And that's how you use formulas.